Okay, hi distance learners. Hi everyone. Okay, so the first thing you're going to do is log into Microsoft Teams. Go into Math. Once you're in the Math notebook, you're going to click on Class Notebook or More, and then Class Notebook. And once you're inside the class notebook, you're going to click Unit 1, which should be displayed under your name. Okay, so I'm going to wait a second for you to get there. Once you're there in the class notebook, you're going to find where it says classifying rational numbers. Some of you, it's going to take a really long time to download. That's because it's a ton of content. Okay, so just give it a second. If you're having problems, just wait a minute, try to log out and back in, but eventually it will come up. It's a lot of stuff if you look through it. Grace, did you have a question?
Yeah, my Wi-Fi isn't.
Okay, so try to log out, log back in for the Wi-Fi, and just keep playing with it. Eventually, I promise it does come up. It's just you got to switch between guest and public and turn it off and on and return on your iPad. If it totally kicks you out of the internet and you need a password, interrupt me and I'll call Mrs. Olson. Raise your hand if you're having internet problems. So just 2 people. Okay, it might be where you're located in the room. Who knows? Okay, I'm going to move on. Most of this you just pay attention to and you don't have to write till a little later. So just keep. Okay, so the very first thing we're going to learn in algebra is called classifying rational numbers. So you know how we were talking about Fibonacci sequence and patterns? And we were saying in math, there's always a pattern which forms algebra. So we take a number, okay, and when you're looking at a bunch of numbers in a row, your brain starts to analyze those numbers. So the first thing your brain is going to do is say, are they all positives, right? Then it'll say, are there any negatives in the numbers? Then it'll start to look, oh, there's decimals and fractions. So your brain is starting to categorize the numbers for you, and then once they're categorized into specific categories and they can be defined, then you're able to actually create a pattern, okay? So the first thing we do is, within patterns, is to find numbers, take the numbers and put them in groups so we can find patterns within that group. Got it? Okay, so we have to know how to classify numbers. This should all look very familiar to you. It was the lesson from last year or the year before. You've seen it before. You've heard the song, hopefully, once I play it later. But the very first thing we're going to talk about is over here, the cup model. So you do need a pen, a stylus, to be able to write with us. Okay, and I'll tell you what to write. So you're going to want to take out your stylus. Okay, and put it in draw mode. So you click on, I think yours is a tab that says draw, and then you can change the color. Okay, so let's talk about natural numbers, okay? This is my smallest cup. We're gonna think of the cup model kind of like those little dolls that fit into each other. So the littlest doll, the one in the very center, okay? The smallest cup. Those are natural numbers. What are natural numbers? A hint, they occur naturally. Peter?
Like 1, 2, 3, 4, and then 6, 7.
Perfect. They are, please write counting numbers. So counting numbers. You're going to write that really small off to the side here. Counting numbers. And then under it, you're going to put Peter's examples, 1, 2, 3, ... Is 50 a counting number?
Yes.
Yes, it is. You can count it, right? Is 282 a counting number?
Yes.
Yes, it is, okay? So you're going to write counting numbers and then put 1, 2, 3, 4, and then ... means etc. forever. Okay? Remember I talked about last year, you should have heard this before, that counting numbers are what we teach our little kids naturally. We start off, when you're teaching a baby numbers, we start off by saying 1, 2, 3, 4, because we can show them one. We can show them 2 items. We can show them 2 on their hands, right? So those are natural numbers. They're the ones you first learn. Then they get a little bit older, and we introduce them to whole numbers, okay? What is a whole number? Ian?
A number that is not a fraction or a decimal.
Okay, not a fraction, not a decimal, good. Keep going, I need more than that. It's more specific. You're very close, and all of that's correct, but it's more.
It is the natural number, but it also has 0.
Good job, that's what you're gonna write. It's natural numbers, so anything that would fit into here, all of your counting numbers, because the cups fit inside each other. So natural numbers plus 0, and you can just use the plus sign. So natural numbers plus 0. Then under it, I'd like you to write the examples. 0, 1, 2, ... Okay? We introduce kids to the concept of 0. 0 meaning nothing, okay? So those don't naturally occur. We have to explain to them what 0 is. We give them cookies and take them all away, right? And say, now you have nothing. Just kidding, okay? So, it's very sad, but true. So we have whole numbers are all of the natural numbers plus 0, okay? Then we have another category called integers, which is a little bit bigger. So natural fits into whole. All the natural numbers are also whole numbers. All the whole numbers are also integers. So what makes this cup a little bit bigger? It's all of the whole numbers plus what? Stefan?
Negative.
Plus their opposites. Not all negatives, because if they're fractions and decimals, they don't count as integers. So integers are whole numbers, so everything that was in this cup, plus, put the plus sign, opposites. And I mean opposites on the number line. Abby, what's the opposite of 7? -7. What's the opposite of 12, Matthew?
-12.
-12. Jada, what's the opposite of -27?
27.
+27. So its integers are all of the whole numbers, all your normal counting numbers, including 0, and then also their opposites on the number line. No decimals or fractions allowed. Okay? So right here we're going to look at this, the definition of integer. An integer is any positive or negative value without a decimal or fraction. Here's examples, and here are non-examples. Fraction, decimal, pi is infinite. These are not examples of integers. Okay? Now we're going to do the next cup, which is our rational numbers. So all of our natural fit in whole. Whole fits into integers. Integers fit into rational. What is a rational number? Logan.
A rational number is a number that does not go on forever, but is lengthier than an integer. So
Okay.
it could be a decimal, a fraction, or a negative.
Okay, that's better. So rational numbers is any number that can be written as a fraction. If you can write the number as a fraction, it's considered a rational number.
Is that what we write? Any number?
It's actually written right here. A rational number can be any number that's written as a fraction. So any fraction. It's also when you turn them into a decimal, or when you're looking at a decimal, they must end and have a pattern. So what are the 2 math words? What is the 2 vocabulary words for end? They must blank. They must, instead of end, what do we say? Jason?
Terminate.
They must terminate. And instead of have a pattern, what should we write there? So instead of end, we're writing terminate. Or what does it mean? Like 3, 1, 3, 1, 3, 1, 3, 1. What's that called in math if it has that pattern at the end? Sophia?
Repeating decimal.
It must repeat. Good job. So it either terminates or repeats. If it ends or it has a pattern that's repeating, it's considered rational. numbers that do not have a pattern, like 0.576132792165, we don't know when it ends, there was no repeating, those are considered irrational numbers. Okay, numbers that don't have a pattern and don't repeat. So under rational numbers, I want you to write fractions. All fractions are rational. All fractions are rational. If you can write the number as a fraction, it's considered rational. Okay? And terminating and repeating decimals. And terminating and repeating decimals. Those are rational. All fractions and terminating and repeating decimals. If it doesn't have a pattern and the number goes on forever, you know those numbers that you divide and they go on forever and you're feeling like, when am I ever going to have to stop this long division? Those are irrational. Okay? If they don't have a pattern where you can stop dividing and they're not ending. Okay, so now, just 1 second, I see that there's questions. Something's wrong here in my non-examples. Which non-example needs to be moved into an example of rational numbers? Which of these non-examples should be in the example category? Grace.
For rational numbers, it should probably be 4/7 because it's a fraction.
Good job. 4/7 needs to be moved over here. So you can either cross it out and rewrite it over here. And now I want you to take your calculator and do 4 divided by 7. And give me the decimal. All numbers that are in fraction. So when you have it, let me know. Okay, Anthony.
0.5714285714.
Notice anything? Logan? It repeats. 571428, 5714. If yours has a 3, it's just the 28 rounded to a 3. Okay, in your calculator. So if yours put a 3 here, it's because 28 was next and 8 bumped the 2 to a 3. So this is actually a repeating, which ends at the 8. Try 1/7. 1 divided by 7. Ian?
I got 0.1428571.
Does it repeat or terminate?
It repeats.
It repeats. Look at it again. When it hits the 1 again, it's repeating.
Oh.
See how your calculator just rounded that back number up? You can look at it and tell, right? Okay, so this one repeats. Here's another one that a lot of people get confused. 2/11. So 2/11. Try it in your calculator. MJ?
0.1818 repeat.
It's repeating. Everybody sees it? Okay, so the 7s, a lot of people get confused because they think, oh, when I divide this, it looks like it's irrational, but it's not. The fractional value with a denominator of 7 actually does repeat. Okay? 11s repeat, 9s repeat. So any value that's a fraction will repeat. It is rational number. All right. Irrational is all of those little extra numbers. So irrational numbers are like pi and numbers like this decimal right here. So if it's not rational, these are actually called irrational. Okay?
So what should we write for it?
So these are all irrational. So irrationals are numbers that don't end and don't repeat. They're decimals that don't end and don't repeat. They produce an pi is an irrational number. It's infinite. It doesn't end. Alright. We're gonna look at the next chart, which looks like this. Okay, we've seen this like circle diagram before, and you'll see it in your homework again and on your tests. What this means is it's the cup model. This natural number is inside of a whole number circle, therefore all natural are also whole. Whole is inside of integer. So this category, if I circle the integer category, integers, these are just integers. If I have them inside of whole, they're whole and natural. Okay, so everything that's small, the smaller circles are also included as what the number is classified as. Okay, so we'll go through some of those. So the natural numbers are 1, 2, and 3. Okay, those are your natural numbers. 1, 2, 3, 4, 5, 6, 7. Then here, these are considered whole numbers. Why is square root 9 a whole number? Why? How could that be? Tessa, how is square root 9 considered whole?
Because if you like square root it, it's 3.
Yeah, because the answer is 3. The square root of 9 is 3, and 3 is a whole number. Okay? What about 7?
7.0 is a whole number because, if you just take away the decimal point, it's 7.
Because it's just 7. Could 3 and 7 also be considered natural? Yes. That's why whole includes natural numbers. Okay? What about 0? Could 0 be a natural number?
No.
No. What about 4 divided by 2?
Yes.
That's 2, right? Or 4 over 2?
Mm-hmm.
So this would be considered the number 2, and 2 is whole. 2 is also natural. So technically we could move this one, and this one down into natural numbers. Okay? Because they're natural, and then they're also whole, considered whole. Okay. Here we have integers. Do any of these look like they're in the wrong place? Are any of these guys wrong? One of them's wrong. Jason?
Is it 10/5?
Negative 10 divided by 5 is negative 2, and negative 2 is an integer. Okay, it's all of the whole numbers and their opposites, so negative 2 on a number line would be an integer. Matthew?
Is it 3.121?
Yes, cross this one out. That is not an integer, that's a decimal. Okay, that is not an integer. Right, look at the next category. Rational numbers. Are any of these in the wrong place? Peter?
Is 1.33 repeating not supposed to be there, or?
Well, it repeats, so it has a pattern, so it should be rational. It is a repeating decimal, which has a pattern. Ian?
14 divided by 4, because when simplified it becomes 7 divided by 2, which is a irrational number.
It is rational still. All fractions are always rational.
Should become,
16.
can we move to natural?
Is there a better place for 16?
Attention please, if all teachers could read your email, please read your email, thank you.
What?
Natural numbers?
Natural numbers.
Same thing with
So I would move this here, just like I told you the other ones, but it is technically rational, yes?
Yes.
Because if it was moved into natural numbers, which is a counting number, it's also considered whole, it's an integer, and it's rational. It's just placed wrong in the diagram. Because placing it here means that it's not the other things within it, and it is. So I would take 16 and put it here. Okay, down there. Then, once you put it in natural numbers, then it's also whole, it's an integer, and it's rational. It's just placed wrong on the diagram. Although it is a rational number, it's not in the right place. Just gonna check my email. All right. I want to point out the irrational numbers. Okay? Is it recording, Logan?
Yes, it
Okay.
is.
All right, so these are all irrational. Okay, if you wanted to, pi is irrational, phi, which you saw in the video for Fibonacci sequence, that is irrational. If you square root 1.6 in your calculator, which I suggest you try, it doesn't terminate and it doesn't repeat. Okay, so it would be considered irrational. The only ones that don't terminate or repeat that are considered rational are the fractions. All fractions are rational. If you can write it as a fraction, it's considered rational. Got it? Okay, no questions about that. All fractions are automatically rational. It's just when they're in decimal form, that's when you decide if they're terminating or repeating. Okay, I'd like you to take these numbers off to the side and place them where you think they go on the diagram. You can cross them off as they go, okay, and then you're just going to place them where you think they should go. Okay, everyone, so you should have placed them in the appropriate category by now, and if not, when it comes to you, just try to place it, okay? So I'm going to call you randomly around the room. So we're going to start with -6, and Tessa, you're first. So where do you think -6 falls?
I put -6 in integers.
Good, -6 is an integer, which means that it's also a rational number, and it's real, okay? What about 2/3, Ariana?
Rational.
Good, 2/3 is rational. All fractions are rational. Okay, what about 25%? Abby?
Is it rational?
It is considered rational. It's 0.25 because you divide by 100. All percents are out of 100, so you'd move the decimal 2 places to the left. Okay, 5.2 repeating. Logan?
Me?
Mhm.
That would be give me a sec, that would be a rational number.
Good, 5.2 repeating. Okay, then we have 8. Ronan?
Counting number?
Good, it's a counting number, which also makes it what?
A whole number, integer, rational number?
Good job. If it's a counting number, it's the smallest little doll, the innermost doll, and then everything outside of it also works. Good job. 0. MJ?
It's a whole number.
Beautiful. It's a whole number, which also means it's an integer and it's rational. Good job. 1. Ian?
1 is a counting number, a whole number, an integer, and a rational number.
Great job. 5. I love how you included all of the categories so that it was easy for me. Stefan?
It's a counting number, whole number, integer, and rational.
Good, we put it in counting because it's all of the above. What about 1/4? Sophia?
It's a rational number.
Good job, 1/4 is rational. What about 12/7? Grace?
It's a rational number.
Beautiful, 12/7 is rational, it repeats. What about -15? Logan?
-15 is a integer.
Is an integer, good job, which also makes it what?
A rational and real number.
Rational and then real, great job. Jada, we're on to 50%.
It'd be a rational.
Good job, rational number, because what is it as a decimal, Jada?
A half.
A half or 0.5, right? Good job. What about 1.08? Anthony?
It's a rational number.
Good. Jason, we have 0.7.
Rational?
Good job. 3.8%. Abby? 3.8%.
Oh, I put that in rational.
Good job, 3.8% is rational. Okay, the next one, -9/2. Matthew,
I did rational.
good, 4.5, which means it's rational. -√7, Peter.
Negative, rational, irrational,
Irrational, good. -0.5, Ariana.
Rational?
Irrational?
No, rational.
Rational. Beautiful. Pi. Jada.
irrational,
Perfect. Never ends, never repeats. The square root of 3/2. Jason.
Irrational.
Good, irrational. MJ, the square root, or 4 square root 5, which really means 4 times the square root of 5.
Irrational.
Beautiful. This number, this really long decimal. Logan.
Irrational. It's just what we have to infer, because it doesn't seem to end.
We must infer because it doesn't seem to end and it doesn't seem to repeat, and eventually all numbers have to end, right? We have to be able to put some sort of end down, unless there's a symbol to represent it like pi. -3/4. Ian.
Rational.
Okay, -8/4. Abby. Integer. Ronan, can you explain why -8/4 would be considered an integer?
because when you simplify it would be -2.
And -2 is an integer, right? If it's an integer, it's also what?
A rational number, not
Be-
rational.
Beautiful, it's also rational and it's also real. Okay, and then we have 3. We're gonna go with Anthony.
It is a counting number and a whole number.
Good, it's a counting number, which means it's a whole number. It's also,
Integer, a rational number, and a real number.
good job, it's also everything else. And then the square root of 20, we're gonna go with Grace.
Couldn't it could be a rational number, but it could also be a counting number.
So if you did square root 20 in your calculator, is it a perfect square? Does any number times itself give you 20?
No.
Then it's gonna be considered irrational. All square roots are pretty much irrational unless they're perfect squares or perfect cubes. Okay? Alright, so now that you have your categories filled out correctly, you are going to look down here, okay? If you cannot get this worksheet displayed for whatever reason, you can click above it on this reteach and it will double click it, it will bring you to the PDF. Once you're in the PDF screenshot, you can write directly on your screen and then you would upload it as a picture once you're done. So if you screenshot it and we write on it, then you're going to go to insert and picture. So you'll put it back into your notes, okay? Does that make sense to everyone?
Wait,
Okay, so if you can't write directly on it for whatever reason, double click the actual PDF, screenshot it so we can write on it, because we're gonna write on it right now. And once you've screenshot it and written on it and you're all done with the worksheet, you need to put it back inside your notebook. So you'd click insert and picture, then click in your camera roll and you can upload it. Jada.
I can't open the PDF.
It should open, try it a few times, double click it.
Yeah, I tried it like 10 times.
Okay. It did work, I think it's just probably loading for you. So if it totally doesn't work at all, just kind of write on the blank screen of your notebook the answers. And then after a while it does show up. It's just so much content. Okay, so we're gonna write each rational number in a fractional form. And then we're gonna circle which set it belongs. So number 1, -12. How do I write -12 as a fraction?
-12/1.
Good job, -12/1, 12 wholes. So what type of number is it then, Logan?
Integer.
Yes, it is an integer, which also means it's
Rational number.
rational. What about 7.3? Wouldn't that be 7 3/10? Is this a fraction? It's a mixed number. Mixed numbers need to be converted into the form a over b or made improper. So if we make this improper, it's 73/10. Now we're gonna classify it. 7.3 is, Matthew?
Wait, what?
What is 7.3? What type of number?
No, it'd be irrational.
A rational number. So this is a decimal. We converted it into a mixed number, but they want us to make it in fractional form. So we're gonna convert the mixed number, which is wholes and fractions, into just fractions, which is improper fractions. So you would convert it, you do 7 times 10 plus 3 to get 73/10. 0.41 would be 41 out of 100, because it's 41/100. That's how we read it. And that's in fractional form, so what type of number is it?
It is a rational number.
Good job, it's just rational. 6, what would that be? Stefan?
6 over 1.
6 over 1? And what type of number is that? Stefan?
Whole number integer.
Good, it's whole, which also makes it integer and rational. So notice you have to, if you circle integer, you circle the one to the right. If you circle whole, you're circling the other ones as well, automatically. You can't be whole without being an integer and rational. Okay? What about 3 and 1 over 2? How do I make that into, from a mixed number into a fraction, Matthew?
You would multiply 3 by 2,
And you get 6,
so 7 over 2.
so it'd be 7 over 2. And 7 over 2, is that a whole, integer, or rational?
Rational.
It is just rational. Okay. So now that we've done this worksheet, your homework is going to be the next worksheet tonight. So distance learners, you have different homework. You're gonna do this as part of your classwork. But the first thing they want you to do is literally just take these numbers and make them into fractions. So the beginning part, you're just converting into fractions, improper fractions. If you wanna write that, you can. Okay, improper fractions. Down here at the bottom of your worksheet, which is your homework, you're just gonna write what category it belongs to. You don't have to place the number unless you want to, but you're gonna write which categories it goes to.
We don't have that.
Yeah, we don't have to.
It'll come through, it's
No,
P.
it's not there in the PDF either.
It will, it's just gonna load. Yep, classify rational numbers, you do have it. Okay, so that's all you're gonna do, and then tomorrow we'll do this bottom part. So you're not, this is your homework tonight, it will load, it's just taking yours a long time. Yep, if you wanna screen share to him, you can.
But not the bottom, right?
So you can airdrop it, not the bottom. Yep, just that one.
I don't think we
No,
can-
that's,
Wait, so what's the name?
your homework is that worksheet.